Assalamualaikum warahmatullahi wabarakatuh. My name is Saifuddin bin Hairudin, AE190005. Firstly, I will conduct the exercise 1A activity 1. So we set up the 5 circuit in this activity 1. We have the voltage source, ammeter and resistance with the voltmeter. And with the all 5 circuit, we have the internal resistance at the voltmeter, which is set up the 10 kilo ohm for internal resistance. So we have the 100 ohm, 200 ohm, 150 ohm, 300 ohm and 1 kilo ohm. So for the simulation, we will run it and we get the value each of the circuit. So all circuit have the same value of the voltmeter, but different the value at ammeter, which is for the 100 ohm 101 milliampere, and for the second we get the 67.67 milliampere, and for the third circuit we get the 51 milliampere, and the fourth we get the 34.33 milliampere, and the last we get the 11 milliampere. Okay, for the next activity 2. So it's look like same with the activity 1, but the difference is we set the internal resistance at the ammeter, which is a 50.5 ohm for all ammeter, and also we set the voltmeter before the ammeter, which is at the voltage source or before the resistance. And for each value of the resistance is same like activity 1 also, 100 ohm, 200 ohm, 150 ohm, 300 ohm and 1 kilo ohm with the same voltage source, 10 volt. So I will run the activity 2. This is the result of the value each circuit, and same like the activity 1, we all have the same voltmeter value, which is a 10 volt for each circuit. And for the first circuit we get the 86.58 milliampere, and for the second circuit we get the 60.423 milliampere, and for the third circuit we get the 46.404 milliampere, and for the fourth we get the 31.696 milliampere, and for the last circuit we get the 9.847 milliampere. So that's all for the simulation for activity 2 and 1.
Okay, next I'm going to present the simulation of activity 3. We have the supply of DC voltage of 10 volt here. We have an ammeter here and voltmeter, and the resistance of 100 ohm. Next we need to set up the internal resistance is equal to 15.5. Then we need to run and record the value of current, which is equal to 100 milliampere. Next we need to change the resistance value here is equal to 150. And then run, and we got the current is equal to 66.667 milliampere, and change the resistance here to 300 ohm. And the current recorded is 33.333 milliampere.
Hi and Assalamualaikum. My name is Muhammad Zikri from Group 3. Now we move to the activity 4. So this is the circuit for activity 4 in the simulation. U-in is the DC source, XMM1 component is the ammeter, XMM2 component is voltmeter, RV is the internal resistance for the voltmeter, and RL is our circuit load. So now we will simulate for 150 ohm value. So we will get the current 67.667 milliampere while the voltage is 10 volt. So next we have to change our variable, which is the loads. So just click this and we change the value. So the table shown is the result of our simulations. So for just now, for load 150 ohms, our current is 0.0677 ampere while the volt is 10. For load 300 ohm, we get 10 volts and 0.0343 for the current. And for lastly for 1k ohms, the volts is 10 volts and the current is 0.0110 ampere. And now we move to the exercise 1b. And now for the activity 1. So this is the circuit for the simulation. We got the AC source which have 10 VRMS with 50 Hz frequency. XMM1 is the ammeter, SMM2 is the voltmeter, and lastly we got RL, which is the load of the circuit. So firstly we will run for the 210 ohm for the loads. So we get the current is 47.619 milliampere while the voltage is 10 volt. So next for the other loads, just change the value on the RL. Then this is the result for the simulations. So for 210 load ohm just now we get 47.619 milliampere while the volt is 10 volt. For 390 ohm load we get 25.641 milliampere while the volt is 10 volts. For 470 ohm, the current is 21.276 milliampere and 10 volts for the voltage. And lastly, for 860 ohm, we get the current 11.628 while the voltage is 10 volt.
Okay, then I will conduct the exercise 1B for activity 2. Okay, I will set up each circuit like this. Each circuit we have the two resistor with a voltmeter with each resistor. So we have the 2 voltmeter and 1 ammeter. Each ammeter voltmeter is the AC, and for voltage source we use the 50 VRMS with the 50 Hz. Okay, for the first circuit we use the 200 ohm with the 390 ohm, and for the second circuit we use the 390 ohm with the 470 ohm. For the third we use the 470 ohm with the 860 ohm, and the last we use the 210 ohm and with the 860 ohm. So I will run the program and we get the each result of the circuit. Okay, for the first circuit, we get the 800 for emitter. We get the 83.332 milliampere, and for this first resistor, we get the 17.5 volt, and for the second resistance, we get the 32.5 volt. Okay, for the second circuit, we get the 58.139 milliampere, and for the first resistance in the circuit, we get the 22.674 volt, and for the second resistance, we get the 27.325 volt. And next, the third circuit, we get the value of the 37.594 milliampere, and for the first resistance, we get the 17.669 volt for the first resistance, and second resistance, we get the 32.33 volt, and the lastly, we get the 46.729 milliampere, and for the first resistance, we get the 9.813 volt for the 200 volt ohm, and lastly 40.8186 volt for the 860 ohm for this simulation. Okay, that's all for the simulation for activity 2.
Okay, next I'm going to present the simulation of activity 3. First, we got the AC voltage here is equal to 10 volt and 50 Hz. We have the AC emitter here also, and voltmeter. So we need to record the current due to these two resistors. So the first one, we need to set the resistance is equal to 210 ohm and 390 ohm. So we need to run and get the current is equal to 47.619 milliampere, and for the second resistor is 25.641 milliampere. Okay, next we need to change this resistance is equal to 390 ohm, and this one is equal to 470 ohm. Then run. We get the value of the current is equal to 25.641 milliampere, and for the second resistance is 21.276 milliampere. Next, we need to change the resistance is equal to 470, and the second resistor is equal to 860 ohm, and then run the program. We record the current is equal to 21.276 milliampere, and for the second resistor is equal to 11.628 milliampere. And for the last one, we need to change the resistor value is equal to 210 ohm, and for the second resistor is equal to 860 ohm, and run the program. We get the value is equal to 47.619 milliampere, and for the second resistor we got 11.628 milliampere.
Pikachu!